In this video, we're going to look at the three different ways that chemists define an acid or a base, and we're going to also look at how they define a salt and how that kind of relates to acid-base chemistry that we've been talking about in class. The first method, known as the Arrhenius method, treats an acid as a proton producer and a base as an OH or hydroxide producer. The advantage of the Arrhenius method is that you just have to look at the atoms in the equation. If there's an H or a proton that's likely to be produced, it's an acid. If it's going to produce an OH group in an aqueous solution, then it's a base. The second method chemists use to determine whether or not a substance is an acid or a base is called the Bronsted-Lowry method. And this, you basically just look for where the proton is coming from or where it's going to. An acid is a proton donor and a base is a proton acceptor. The best method, but most difficult method as well to determine an acid or a base, is called the Lewis method. And with this, you basically just look at where the electrons are moving, which is really good practice for later chemistry. If it's a Lewis acid, it's going to be an electron acceptor, and if it's a Lewis base, it's going to be an electron donor. The main advantage of the Lewis method is that it includes acids and bases that would not be included in the Bronsted-Lowry method. Basically, in the reaction between boron trifluoride and ammonia, you wouldn't be able to recognize those as an acid because it doesn't have a hydrogen or OH group on it, but it is still considered by chemists to be an acid-base kind of reaction. So finally, we get to the question, what is a salt? A salt is basically just another word for an ionic compound. It's what's left over in the reaction between an acid and a base that create water, and you're left with an ionic compound. A positive and negative thing will come together and they will form an ionic compound, which is a salt. For example, if you look at table salt is composed of sodium chloride, NaCl, and basically how you would get it is you would combine a strong acid such as hydrochloric acid and a strong base such as sodium hydroxide, NaOH, and the OH part and the proton from the hydrochloric acid would combine together and form H2O, which is just water, and you would be left over with Na plus and Cl minus, and so the sodium and chloride atoms would be ionically attracted to each other and form NaCl. They'd probably just be floating around for the most part until you let the reaction precipitate out, either through boiling or if you occupy the electric charges in the water with other things. All right, that's all we have for this video. Leave a comment below with any questions you might have about stuff that I didn't cover, and I'll be sure to respond. Also, if you could, if you're in my class, please go out and explore on the internet and find maybe an example of an acid and base reaction, and just let me know which one's the acid and which one's the base, and I'll see you guys in class. Thanks for watching.